Picture this, if you will. A star, ancient and massive, reaches the very end of its long life. In a final, desperate act, it collapses under its own immense gravity and then explodes in a cataclysm of unimaginable power. A brilliant wave of light rushes outward, a silent shockwave of gas and dust across the vast black canvas of space. We paint it in our minds with crimson, gold, and sapphire. Our earthly intuition insists it must be deafening. Yet in the theater of the cosmos, there is only silence. The star dies without a whisper. Bring that same colossal event to Earth, and the air itself would thunder. Because sound needs something to push. In space, there is almost nothing to push at all. To understand the silence of space, we must appreciate the mechanics of sound. Sound is a wave of pressure, a disturbance that propagates through particles. Strike a drum. Its surface vibrates, pushing and pulling on nearby air molecules. Compressed molecules bump neighbors, which bump the next, carrying the wave outward. Sound is a mechanical wave, faster in denser media, swifter in water than air, far faster in steel. Like a stadium wave, people rise and fall in place. The motion travels, the crowd does not. Space the dominoes too far and the chain stops. Without contact, the wave cannot form. Because sound needs matter, it cannot exist in a true void. Mechanical waves require a connected medium. Without it, energy simply fades at the source. Now, back to the heavens. Space is profoundly silent because it is a near-perfect vacuum. A vacuum is a region largely devoid of matter. Even our best chambers leave stray atoms behind. Interstellar and intergalactic space are emptier than anything we can manufacture. Not utterly empty. There are stray atoms, ancient radiation, dust, and high-energy particles. But density is everything. A few atoms per cubic centimeter in space versus quintillions in air. Atoms are too far apart to sustain a chain reaction of pressure, like dominoes miles apart. That is why roaring space explosions in movies are fantasy. In reality, there is light and debris, no bang. Outside pressurized cabins, physics imposes profound quiet. The universe conducts its most violent events in near total silence. If sound cannot travel the vacuum, how does sunlight reach us? Through a different kind of wave. Electromagnetic waves. Light, radio, microwaves, X-rays, gamma rays. Unlike sound, they need no medium. They are oscillations of electric and magnetic fields. A pond ripple is mechanical. A beam of light is electromagnetic. These waves are quantized into photons, traveling at the fastest speed, light speed. Light is the universe's messenger, crossing eons to carry temperature, composition, and motion. Mechanical waves push matter and fail in vacuum. Electromagnetic waves are field fluctuations and pass perfectly. We can see a silent explosion because light arrives as EM waves, while sound, the mechanical wave, never forms. Outside the spacecraft, shouting goes nowhere. The solution relies on radio waves, electromagnetic messengers. Their microphones convert voice into electrical signals. Transmitters turn those signals into radio waves. Receivers convert them back to sound inside the helmet air. A tiny speaker recreates sound in a personal bubble of air, nearly instantaneous. Inside the ISS, pressurized air carries normal sounds, voices, fans, clicks, and hums. Suit radios relay to the station and onward to Earth, a lifeline of invisible waves. Step outside again, and the universe goes quiet. Space is silent, but scientists translate data into sound, a process called sonification. It is not literal sound from space. It is data rendered audibly to reveal patterns. Map pulsar flashes to notes and a hidden rhythm emerges, a cosmic drumbeat. Voyager's measurements of charged particles became haunting audio, emotion layered onto analysis. Human hearing excels at patterns, timing, and timbre, perfect for finding subtle signals. Sonification can spotlight black hole mergers or faint pulsar beats that hide in plots. It adds an auditory dimension to exploring the silent void. We do not hear space, we hear meaning in its data. As we push farther, vacuum silence remains a constant constraint. We will lean ever more on electromagnetic communication, especially radio and lasers. Even at light speed, deep space delays are inevitable. A Mars call can take up to 45 minutes round trip. No live conversation. Future crews will communicate more like email and texts than phone calls. Lasers boost data rates. Think HD video from Mars. Yet delays still rule. Inside habitats, sound matters. Engineers tame fans and pumps. Alarms and voice cues safeguard crews. Silence outside, sound inside. The balance is both an engineering and psychological frontier for explorers. In the end, space's silence is a teacher that challenges our earthbound assumptions. On Earth, sound is everywhere. Rustling leaves, crashing waves, laughter. But the grandest cosmic events unfold in a majestic, silent ballet. To explore, we build new senses. Seeing invisible light, feeling space-time, tasting alien air. Each radio beam is a small voice piercing an infinite quiet, information instead of sound. If space is completely silent, what else about the universe challenges what we think we know?